Hello friends, today we are going to discuss about memory management in JavaScript. Memory management is required in when we allocate any object or create objects or variables. These are provided memory either in stack or on heap. So local variables while running a program are allocated memory on the stack, but the objects are created on the heap. And as the program proceeds, it is important to delete the previous objects that we have created. Otherwise, it will bloat the memory and your process will crash. So in JavaScript, there is an internal program which keeps running frequently. This garbage memory, and this program is called garbage collector. So before diving deep into the concepts of garbage collector and how it deletes the memory, which is not required, let's understand few concepts. For example, the reachability, which is an important part of garbage collector. On the screen, you can see one snippet of the code where I have created one variable called person and it is pointing to an object. And this object is allocated on the heap. So if we create this person equal to null, what will happen to this object? It is not reachable, correct? So this has to be removed from the heap. Let's take another example. Here I have created one another variable which is pointing to this person. So the underlying object for both the variables, whether it is person or human, is same. Now if I make this person equal to null, then the object is still reachable using the variable human. So in this case, the object should not be deleted. So if we look this code through diagrammatically, so here there is a variable called person and it is pointing to an object which has only one key, name equal to Rohit. If I make another variable one and if I now make this connection null, then the object is reachable using human. So this should not be deleted in that case. If we make the human equal to null, then this object should be deleted. That means the concept of reachable means if a variable can be reached or not. Let's take a look into another example. So there is a function called build relation and it is taking two variables as argument, the boy and girl, and it is assigning the boy as a brother of that girl and the girl as a sister of boy and returning a new object. So here we have a family which is storing the returned result of this build relation. So if I run this program, you see we are printing family, which is an object, and this object contains two variables, sisters and brother, and sister object is pointing to another object which is having two keys. One is name and brother key is having another object which is pointing to this particular. So they have a circular dependency. So if I plot this, plot of that code will look like this. Here family object is pointing to an object which is having two keys, right? The Rohit and Reena, and they are the brothers and sisters. If we remove this link, that means Rohit can be reached through Reena because she is a sister of Rohit. So this object is still reachable. But if we remove this link as well, then both Rohit and Reena are not reachable and this particular memory should be cleaned up. So I hope you got the concept of reachability. So now let's take a look into the garbage collector algorithm, which we call mark and sweep algorithm. What it does. So mark and sweep algorithm start with root and start marking the objects which are reachable. So in the first phase, it is reachable through these objects. And then in the second phase, the other objects which are reachable are these, right? In third phase, this object is also reachable. But all these objects are not reachable from the root. That means these objects are garbage and these can be cleaned up. So our mark and sweep algorithm will clean up these three objects. And this program, a garbage collector, keep running every few intervals so that memory will not be bloated. As you can see, this algorithm may take multiple phases and there can be some time delays. So to remove those time delays, there are few optimization techniques which different algorithms use. So mark and sweep is a general algorithm which is used by multiple languages which has automatic memory management, just like Java, JavaScript, Python. And in JavaScript, there are few techniques JavaScript engines basically uses. Few techniques are, first technique is generational collection, which means it will divide the objects into two generations, the old generation and new generation. The new generation objects are those which are allocated recently. So there are higher chances that these objects may not be required and these can be garbaged sooner. But if some of the objects which become older, that means there are higher probability that they may be required. So these will be collected at a later stage. So for the new generation objects, the garbage collector keeps running frequently, and for old generation objects, garbage collector takes some more time to run to remove these delays. The second technique is incremental collection. In this technique, basically it will divide the objects or the whole object graph into different pieces, and whenever first piece is collected, then it will move to second piece and the third part. With third technique, idle time collection. So garbage collector will not run after every interval, but it will try to run when there is no CPU usage to remove any delays in the execution of the program. So this is all about garbage collection in JavaScript. It is an important technique because it limits the resources and our programs will not crash. Also, if you have worked in languages like C++, they do not have automatic memory management where programmer has to do memory management. It is a very tedious task and very wizard bugs got introduced because of this memory management. So I hope you understood the concept of garbage collection. If you like the video, please share with your friends and subscribe to the channel. Thank you.